Lesson 5-4, Compound Inequalities. An inequality is an expression that is not equal to a number. So you will not see an equal sign in an inequality. It usually includes a set of numbers, and it is usually represented with a less than, a greater than, a less than or equal to, or a greater than or equal to symbol. So both of the examples you see here are examples of inequalities. This says 3x minus 4 is less than 8. So if you solve it just like you would a two-step equation and you solve for the variable, then your answer for the first one would be x is less than 4. So that means that if you put 4 in for x, then that would make this statement true. And then the bottom one actually comes to a decimal point. And again, if you solve it like you would an equation, just without the equal sign, you would get y is greater than or equal to 10.5. Compound inequalities involves two inequalities in one statement. A compound inequality is only true if both inequalities are true. So if you have two inequalities together and one of them is false and one of them is true, then that compound inequality is not true. There's been a mistake. The graph of a compound inequality includes an intersection of the inequalities. So a compound inequality shows where the two inequalities will cross over each other. So let's look at this example. It says 3 is less than or equal to x, and x is less than 7. So you actually want to take this apart and you want to do it in two different inequalities. So if we take it apart, then we have x is greater than 3 and x is less than 7. So if we graph that, then the graph for this one is a closed circle on 3 because it's including 3, and it goes to the right. The graph always goes in the same direction as the arrow for the inequality. And then the graph for y is less than 7 is 7, but it's not including 7, and it's going to the left. So if you were to draw a compound graph on this one, you would draw your line. You would have 3 with a solid circle, and your arrow would go this way. And then you would have a 7 with an open circle, and your arrow would go that way. So therefore you can see that all of these numbers are the ones that overlap to make this inequality true. Pause the video to try a few examples. Solve, then graph the solution set for each compound inequality. So for the first example, it is 6 is less than or equal to r plus 7 is less than 10. So you want to pull these apart and then you want to begin solving. So for the first one, we would have r plus 7 is greater than or equal to 6. So that means that r is greater than or equal to negative 1. And then we have r plus 7 is less than 10. So that means r is less than 3. So what this means is you have your negative 1 and your circle is filled in. And so it's all the numbers to the right of that. But you have 3 and it's not including the 3. So it's all the numbers between negative 1 and 3, including negative 1. For the next one, they've actually broken this one apart into two different inequalities for you, but it's still a compound inequality. And so we have y minus 3 is greater than or equal to negative 11. So this one would be y is greater than or equal to negative 8. So I'm just going to go ahead and graph that one. So negative 8. And then the next one is y is less than or equal to negative 5. So you graph your negative 5, and it is including it. And everything less than that would go this direction. So that would mean that the number for y is somewhere between negative 8 and negative 5, and it could include both. Now we're going to talk about graphing a union. The word and indicates and includes the numbers in the set. So the previous example that we did was an and statement. So it included the numbers within that compound inequality. The word or shows a union of the two sets. So it doesn't necessarily include the overlap, but it kind of includes all the numbers within the set. So let's take a look at this example. It says negative 2m plus 7 is less than or equal to 13, or 5m plus 12 is greater than 37. So if we solve this equality, one inequality at a time, the first inequality, negative 2m plus 7 is less than or equal to 13, gets simplified down to negative 2m is less than or equal to 6. And so your m, remember when you divide inequalities, you have to flip the sign. And so your inequality becomes m is greater than or equal to a negative 3. So we want to graph that inequality. So we want to have our graph, and we say that it is greater than or equal to negative 3. So negative 3 included, so we color in our circle, and it's all of those numbers. 5m plus 12 is greater than or equal to 37. You get 5m is greater than or equal to 25, and m is greater than or equal to 5. So now, if we draw this graph, we can have the same line, but it now just starts at 5. It includes 5, and it's greater than. So now if you wanted to find the union between these two graphs, you would look at the areas and say, well, I have to start at negative 3, and I have to cover all the numbers because 5 is included in those numbers. So you could just very quickly draw a graph of your negative 3 and all the numbers included. Pause the video to complete the lesson review. Solve and graph each inequality. Make sure you show me this lesson review for verification of watching this video.